In this video, I'm going to go over homework 4, 5.59, and the first one, the answer is yes, it's a binomial distribution, because we have fixed number of trials, so we're going to do the trial 10 times. It has to be fixed. Each trial, we only have 2 outcomes, because we want to know if 6 shows up or not. So there are only 2 outcomes. Either 6 shows up or 6 does not show up for each trial. Each trial in this case is we just throw the die. And the second one, B, is no, because it asks for the number of times we roll the die in order to guess the number. It's not a fixed number of trials because we don't know how many times we have to throw the die to get a certain number. So it's not. C, and the answer is yes, because we want this time we want a number, not just one number like 6 or not 6. We want a number either 1, 2 or other numbers. So we do 3 times. We throw the die 3 times, and so it's a fixed number of trials, and also each trial we throw the die and we want to see if we can get a 1 or 2, or maybe not. So we want to get either 1 or 2. And in this case, that we have, because then we have 4 ones. Actually, I'm sorry, this is the drawing the numbers out of there. And let's look at week 4, the homework. So the problem says in the jar we have 10 marbles. So we want to draw a marble, and if the marble is numbered either 1 or 2, then we say, okay, this is a success. If we don't get 1 or 2, we say it's a fail. So each trial, each drawing, there are only 2 outcomes. We get 1 or 2, or we don't get 1 or 2. So it is binomial distribution. And because we have, you can see we have 4 1s and 3 2s, so altogether we have 7 marbles out of 10 marbles. So the probability of getting a success, which is you get a marble 1 or 2, that is 7 out of 10. Okay, so that's why we should have 7 out of 10. And 5.61, and in this question, it's very easy. We just need to follow the formula. The formula given is, we proved this formula in class, and this is n choose x. P means this probability of success raised to x times 1 minus p. This 1 minus p is the probability of failure, and raised to n minus x. So following the formula, because in this problem it's given x equals 3, n equals 6, and the probability of success is 0.25. So we just plug in numbers. So n is, when you see n is 6, this little x is 3, so it's 6 choose 3. P is the probability of success, which is 0.25. So 0.25 raised to little x again is 3, so raised to 3, and times 1 minus 0.25, and 6 minus 3. n minus x is 6 minus 3. So you can use your calculator to evaluate this, and we get the answer. So notice that x is exactly equal to 3, and this is the formula we use if we know x equals exactly 3. So it's like out of 6 trials, and we want 3 successes. What's the probability? So the probability is 0.132. Your numbers may vary a little bit because when you choose, it depends on how many decimal places you choose. So if it's a little bit of it, different, then that's okay. You may have a small error. Okay, and 5.68. This question is different. Let's look at 5.68. So we have okay, wait a second. So it's right here. 5.68. Rh positive blood appears in 85% of the white population. So that means if you go ask someone randomly, pick someone from the street, and you ask him if he's Rh positive blood, and the probability is 85%, or you can say 0.85. That means Rh negative is 0.15. So if 8 people are sampled at random, so we gonna ask 8 people about their blood, see if they are Rh positive or Rh negative. Part A, at least 6 of them have Rh positive blood. So that means we want to, out of 8 people, what's the probability of at least 6 of them are all Rh positive? That means either 6 or 7 or 8. 8, because we're going to ask 8 people. So at most, you will have all of them. 8 people have Rh positive blood. So in this case, it's not asking probability like the previous question, probability of like 2 success or 3 success or 2 success. Here, the success, we're going to consider it as Rh positive blood. So the little x is not exactly equal to 6, is greater than or equal to 6, because it can be 6, 7, or 8. So in this case, we have 2 different ways of doing this problem. So like in the solution, what Stephanie did was this way, because we want to find out probability of at least 6 or 7 or 8 people have Rh positive blood. So we find out f of 6, again using the formula from before, which it's right here. So you plug in n equals 8, x equals little x equals 6. So always remember this formula only applies to x, the capital letter X equals little x equals a number. So like equals 6. So we plug into the formula like below here. So n choose x, so 8 choose 6. P 8.85, that's the probability of Rh positive raised to 6, and 0.15, that's the probability of Rh negative, and squared. So we simplify it, use calculator, and we find out 0.2376. So similarly, we can find out the probability of exactly 7 people having Rh positive blood. So this one, 0.2376, means that exactly out of 8 people, 23%, 0.76% chance that 6 of them are Rh positive. So you can see it's a little bit low. And then 7 people, and then we use the formula again, because this capital X equals 7. So we can do little x equals 7. So we can use the formula, this formula one more time right here, this formula, and choose x times p raised to x times 1 minus p times raised to n minus x. So we plug into the formula one more time. So this time is n 8 to 7, and p raised to the 7th, and a q 1 minus p raised to the 1st. And then we do it for little x equal to 8. So 8 choose 8, p raised to 8, and 0.15 raised to 0. Be careful here, a correction here should be 1. Any number raised to 0 should be 1, not 0. Okay, so here, this should make a correction here. And so after we find all these numbers and we add them together, we get a 0.8948. So that's one way to do the problem. But we have a quick way to do this problem. We can use the table given in the homework. So under the homework, if you go to week 4 and under homework 4, I have a table given, a list, a link. So you can open the link, and this is the table. What this table tells us is for the cumulative probability of obtaining X successes in n tries with we having at least X success means sorry, at most X successes. So always remember this table only applies to X is less than or equal to a given number. So if we try to do this problem here, because we are trying to find out the probability at least 6, not at most 6, but we know at equals at least 6, that basically means the number 6, 7, or 8. Or we exclude the number 0, 1, 2, 3, 4, 5. So the probability of at least 6 is equal to the 1 minus the probability of at most 5. And for at most 5 successes, we can use the table. Always remember, the table only works for at most some number. Okay, how do we use this table to find out that? First of all, we know n equals 8, so I'm going to look at n here, 2, 3, 4, 5, 6, 7, 8. So I found right here the page with n equal to 8. And then I look at p, because the p, RH positive is 0.85, so I found right here. And then at most 5, it's right here. So little x is at most 5. So I will go down to 0.85. So this row and this column, 0.8285 column. So I found out it's this right number right here, 0.1052. So that's why I have 0.1052 for at most 5. And then the probability of at least 6 is equal to 1 minus the probability of at most 5. So that's how I get it, 0.8948, which is exactly the same as doing it this way. Okay, so the second question, part B, we can do it similarly. What she did was to, because this question is a little tricky, I might have been a little misleading in class, wasn't being very clear. In this homework question, part B, it's looking for at most 3 of them have RH negative instead of positive. So RH negative, you can either do at most 3 negative, which means because we have 8 people, that means at least 5 positive. So you can do that way, or you can just do at most 3. So if you use the table, it will be very easy. At most 3, because the table applies to at most. So at most 3, but we are talking about negative, so the probability is 0.15. Instead of 0.85. Again, look at the question one more time. 85% are RH positive, which means 15% is RH negative. So that's why it should be 0.15 or 15%. And then we go to the table again, n still equals 8, but this time p still equals 0.85, but the little x is at most 3. So I look at this row, and we are here. So it's 0.0029. Oh, well, looks like I made a mistake right here. So it's at most 3. Oh, I'm sorry. I shouldn't look at the 0.85 because this time we should use 0.15. So look at the table again. 0.15 is this column right here. So m equals 3. So it's 0.9786. Okay, so that's how we got the answer. 98787.